Good afternoon. My name is Chris Bell, and today I'm going to demonstrate how a simple motor starter circuit works. If you'll see here on the board, what I have is a simple stop-start motor starter circuit. This is actually a holding circuit as well. This is a latching circuit. Okay? But first, before I start, we need to become familiar with some of these terms and symbols on this schematic that I have to be able to understand what we've got here. So, as you first see, we have a stop button and a start button. Now, on a schematic, a stop button is represented by what's called a normally closed push button. Okay? Now, that is represented by a normally closed symbol that looks like this. Normally closed symbol. That is what a stop button looks like on the schematic. Now, moving on to a start button, it is the opposite. A start button is normally open. Just like you see here, the gate is open that lets it flow across. Okay? Now, what happens is when the start button is depressed, it lets the flow of electricity go over to this next symbol that we see. That is our motor starter. Now, guys, a motor starter is this device here. This is what it physically looks like. This is what it looks like on the schematic or line diagram. Now, when I see this symbol with the circle with the M inside it, that tells me it's a motor starter. Now, on that starter, we have what's called a coil. This is has a coil on the inside that I have to energize to make this starter work. Once this coil is energized, it has electromagnetic coils in here that pulls this connection down, which lets the flow of electricity flow in the top of the starter and come out the bottom. When this coil is not energized, electricity cannot come out the starter. It can go in, but it cannot come out because the connection, the coil is not energized, letting the flow go all the way through. Now, we have seen what a push button looks like. You have the stop push button, start push button. This is our motor starter coil. Now, this brings us to an important piece right here. This is a latching circuit or a holding circuit that you see right here. What this enables us to do is when we press the start button is spring loaded. So when I mash the start button and turn loose, it pops back to its off position. So this holding circuit enables me to take my finger off this push button and this motor continuously run. How it does that is when this coil is energized, this connection that is open becomes closed. Okay? So virtually we go from open to closed when this is energized. Lets the flow go from my power source, line 1, all the way through my stop button, through my start button to my motor starter coil. But when this button retracts, the flow continues to go this direction around the start button, letting me take my finger off that start button and this motor run automatically. Now, to stop this, all I simply do is press the stop button and it breaks the flow going to my motor starter, which kills my circuit. So, now we're going to physically wire this and hook this up. Okay? So, if you see here, I have all the parts to do this. Now, a power source will consist of a simple 120 volt cord that you see right here. Now, this cord, I've already cut the ends off and exposed the wires. In a 120 volt system, we have 3 wires, black, white, and green. The black is my power, the white is my neutral, the green is my ground. Okay? The black wire is going to simulate line 1 on my schematic, while the white wire is going to simulate the neutral on my schematic. Okay? So, what I'm going to do is, from my power source, typically this would be coming from a breaker box or disconnect or something like that. But for today's sake, on showing you this, I'm just going to come from a cord, wire this up then we'll plug it in and physically see it run. Okay, so let's make our connections here, and what I'm going to do is I'm going to strip this wire back. I'm going to come out of my power source from my black, twist these together in a clockwise fashion. I must go clockwise because if I go counterclockwise, when I put the wire cap on there, it will come loose if I do not go in the clockwise fashion. Thread the wire cap on. Now, I'm going to run my first wire into my stop button, which is normally closed. Get my stop button. Come into one side of the normally closed. Tighten this back down. Of course, y'all know the rule of thumb. Clockwise to tighten, counterclockwise to loosen. So now I have made my first connection from my power source over to my stop button. Let's see. This connection right here. That is made. Now I'm coming with my second wire from my stop button over to my start button. So strip the wire back. Come out of my normally closed side of my push button. Now I'm going to go over to my start button. Now, instead of normally closed, this is a normally open contact on my start button. Come into one side of my normally open, tighten that down. Now the connection I've made right now is this connection right here. Okay, now I always read these schematics left to right, top to bottom. So I'm into one side of my start, now I need to come out of my other side of my start to my motor starter coil. So I'll run that wire right now. Come out of the opposite side of my start button, which is normally open, to the coil on my motor starter. Now, as I said earlier, this is the coil up here on the very top. I'm going to come in on the left side of the starter. Twist these together in a clockwise fashion and put a wire cap to keep them secured. Wire cap here. Now, what I've done, we'll come back to my schematic and mark off where I'm at. This schematic acts like a blueprint for electricians as well. It shows exactly where I'm at any given time. Now I'm going to come from my starter, out of my starter, to my neutral, back at my power source. I like to use white on my neutral disc to kind of color code it. I always associate, especially with a 120 volt system, I associate neutral with white. So, wire cap on this, and this in turn goes back to my white wire on my power source, which is my cord. Right here, we'll twist this in a clockwise fashion. Okay, so I'm just about complete. I've now made my connection from my starter to neutral. Now I need to come back and catch my holding circuit right here. Now I wanted to come off of one side of the start down to a open contact, which is an auxiliary contact block on the side of my motor starter you see right here. Now that is an open contact that I need. So what I'm going to do is I'm going to tie in to this wire right here on this side of the start button to an open on the contact on the side of the motor starter. So I'm going to loosen the screw wire under the screw to make the connection and retighten this. Okay, now I'm going to run my wire over to the open contact on my starter, which, as you can see, is on the very bottom right here. So I'm going to loosen the screw. Make my connection right there. Now, go back to my schematic. I'm going to mark off what I've just installed. This wire right here. Okay? Now I have one last wire to make, and we'll have completed that. Okay? Now coming from the opposite side of my start button, right here, down to the outgoing side of my auxiliary contact block here on the bottom. Strip this wire back, and it installs on the opposite side of my start button to make that holding circuit, which enables me to take my finger off this start button whenever it is running and continue running the whole time until the stop button is pressed. Okay. Now, everything is wired. The only thing I like is actually making my connections from my starter to my motor itself. Now, I'm going to simply bring this around and install that right now. This is the outgoing side of my starter, which I'm going to connect my motor to. I'm going to color code this black on one side, loosen the terminal and actually put the wires underneath them. Installing the neutral wire right now. Now the ground wire is the last one I'm installing. Now, I've connected my motor to my starter. Now, I just need to supply power, direct power, to the top of my starter that's waiting on that motor. Once this is magnetically energized inside, it will close that contact and let power go to my motor itself. So, I'm going to install, what I've done, I basically took a extension cord, cut the ends off of it to give me a black, white, and green wire. I'm going to connect it to the power source for this. So all I'm doing is I'm making connections on my terminal strip right here for that. Black, the white goes in the center. And green on the very end to match the ones that we just installed. Like so. Now, I've got my connection made on my starter. I'm just going to run my cord back up to my power source and make all my connections right here. Twist these together under the screw to supply power to that motor starter for that motor once that coil is energized. Twist these together in a clockwise fashion. We're just about done. Connect my neutral wire. Now I'm going to connect my ground wires and twist those together and put a cap on them, and we'll be ready to test this. Now, my connections is made. I'm going to plug this into the power source and we'll test our motor. Now, power supplied, so once I mash the start button, this motor will run until, there we go. The stop button kills the circuit. So there's the basic stop-start circuit. Hope you guys enjoy.